In this demo, we will benchmark the performance of the string builder. We'll re-implement the sales data writer using a string builder and compare the allocations of both approaches. We'll re-implement the sales data writer using a string builder and compare the allocations of both approaches. Earlier, we implemented this sales data writer to produce a CSV export of the processed sales data. We used string.join and string.concat to conveniently produce our final string. So that we can benchmark the difference between using a string builder and the string methods, we'll create a new report writer that repeats the functionality. I'll copy this current implementation and open the StringBuilder Sales Data Writer class. I'll paste in the current code and then we can refactor it. We'll begin as we did in the last clip by creating an instance of a string builder. This method uses async code, so we need to add the async keyword to the method signature. We'll then need to append each piece of sales data to the string builder. We could do that directly inside this loop, but to make it more reusable, we'll add a method to the historical sales data class. We'll create a new method here named produceRow. It will accept a culture info and a string builder instance. The logic here will be pretty similar to the getFormatted_components method above. We'll append each property to the string builder. We'll begin with the date of the sale. We want to format this correctly, so we'll use the append_format method this time. This method accepts a culture info for the format operation as the first argument. The second argument is a format string. Just as we did when we used the format method, we can include a placeholder for our formatted value. We'll be supplying a single value to be formatted, which will have an index of 0. This will be a date, and we'll provide a format component with the lowercase u to use the universal sortable datetime pattern. The final argument will be our UTC sales data property. As a reminder, since we're using the universal format, we don't strictly speaking need to provide a culture. I still prefer to explicitly provide one to avoid any future bugs from creeping in if the format were to change. We can then append our string properties using the append method. I'll chain a call to append a comma after each of these. Append has an overload accepting a char, which is sufficient for our requirement here. We'll do this for the product sales code, SKU, product name, category code, and currency. We'll use append format, passing in the culture for the unit price, and a format string that will use the number pattern with 2 decimal places. We'll do the same for quantity and sales tax percentage, but with 0 as the precision specifier. We'll conclude by calling append line to finish the new row. This completes our produceRow method. We'll return to our writer to use it. Inside the loop over the sales data, for each item, we'll call the produceRow method. We pass in the application culture and our string builder instance. After this loop completes, we should have all of our data inside our string builder. We can call toString on the string builder inside the writer loop to produce the final string. To compare the relative performance of our original report writer with our new StringBuilder based implementation, I have prepared some benchmarks inside the Sales Data Writer Benchmarks class. This is a slightly more complex benchmark than we've used previously. Inside the setup method, it creates some processing options. To avoid measuring the overhead of logging or writing the output files, the benchmark uses a null logger factory and a no-op output writer, both of which are stub implementations. It then creates an instance of each writer that we wish to compare. This code creates and populates a list of historical sales data records. The size here comes from this property marked with a benchmark.net params attribute. This includes 2 values, 1 and 100. Including multiple params will cause our benchmarks to execute once with a list of 1 sales record and once with 100 records. This will allow us to compare something quite interesting when we view the results. Below the setup, we have two benchmark methods. The first calls write async on the original sales data writer, which used join and concat. The second calls write async on our new StringBuilder implementation. We need to update the program class to execute the sales data writer benchmarks. We're ready now to execute these benchmarks, so I'll set this to release mode and change the startup target. Let's run the benchmarks. I'll again speed up the video here to save some time. Because we have two benchmarks and two param values for the size of the sales data list, 4 benchmark runs will occur. With these complete, we can observe the summary results. In the first 2 rows, we see the results for producing the string for a single record. It may be surprising that when using the string builder, it performs nearly twice as slowly and allocates more bytes. This is because the string builder class has some allocation overhead. We'll learn more about how it functions after reviewing the implementation details. For a single record, the overhead is more significant than our use of join and concat for a small number of strings. Once we increase the number of records being written, the benefits start to show. For 100 records, the string builder writer executed more quickly, and most significantly, it allocated around 18 times fewer bytes. This illustrates why it can be so essential to consider using a string builder whenever you combine more than a few string values. With our benchmark testing completed, we must not forget to reset the startup target and return to the debug build configuration.